So this is going to be further on the star conditions which we had discussed in the previous lecture. So we will try to understand more on the A star, T star and the other quantities associated with the star condition. So your A star is something that we had seen is obtained when a point is reduced to a location where your Mach number is 1 and the process is isentropic as compared to your stagnation point where your Mach number is 0. So, if I have a flow arbitrarily shaped duct, so if my area is changing along one direction, assume 1D. So, I have section 1 and section 2. There is no Q, there is no shaft work. So, I would draw the TS diagram for such a process from 1 to 2. So, 1 has a star value somewhere here, 2 has a star value somewhere here. For the time being, I am drawing it in the same line. We will see why it is in the same line. So, at the point 1, I also have a state which is the stagnation point, which is my 0, 1. So, with the point 2, I also have the stagnation point, which is the same as T0, 1. Since there is no Q, there is no shaft work, but we also know that the pressure, stagnation pressure of 1 and stagnation pressure of 2 are different because there is a irreversibility associated with the flow. Now, we will see what is the relation between the star states of 1 and star state of 2. So, our aim is to find the relation between A star 1 and A star 2. So, we have obtained this particular relation A1 by A2, which depends on the Mach numbers of 1 and station 1 and 2, will be 1 plus gamma minus 1 by 2 m1 square divided by 1 plus gamma minus 1 by 2 m2 square divided by m2 by m1. So, this would be gamma plus 1 by 2 gamma minus 1 into e power minus delta s by r. For the process A is A1 star and A2 is A2 star, then my M1 is 1, M2 is 1. Which tells me A1 star by A2 star is e power So, I have this relation. I also know P02 by P01 to be e power minus delta s by r. Which tells me A1 star into P01 by A2 star into P02 is 1. So, my changes in star is essentially due to irreversibility, and changes in pressure, stagnation pressure, is also due to irreversibility. So, this is the relation between these two reference points, where I can write this when there is no heat transfer, there is no shaft work, and there is no potential also. So, there is irreversibility associated with this even when we write this relation. So, this is also applicable to irreversible flow. So, my star value at location 1 and the stagnation pressure at location 1 is related, the area and the stagnation pressure is related to another point in this particular fashion. Okay. Now, moving further, I have the energy equation between point 1 and 2, okay, between the point 1 and 2. Now, associated with 1 there is a star value, associated with 2 there is a star value. So, if I consider 1 star and 2 star, then this is H01 star equals H02 star. What I have written here, if I substitute the star values, it is the enthalpy, stagnation enthalpy equating, because the Q here is 0, the W here is 0. So, I can write T1 star plus V1 star square by 2 equals Cp T2 star plus V2 star square by 2. Since it is a star quantity, I can replace at star my m equals 1 or my V star equals my A star. So, I can replace my V1 star with A1 star. So, what I will do is Cp, I replace it as gamma r by gamma minus 1 T1 star plus A1 star square by 2 equals the other side, the second point, T2 by gamma minus 1 star plus A2 star by 2. So, this is the star condition at the LHS is the star condition at 1, RHS is the star condition at 2. So, I will rewrite that whole thing here. Is gamma r t star 1 by gamma minus 1 plus a1 star by 2 equals gamma r t2 star by gamma minus 1 plus a2 star by 2. So, gamma r t1 is the velocity of sound square. So, I can replace that with this. This would be a2 star square by gamma minus 1 plus a2 star square by 2. So, if I take a1 outside, 1 plus gamma minus 1 plus 1 by 2 equals a2 star square with the same quantity. It just means a1 star equals a2 star. So, if I have a irreversible process from 1 to 2 and I take point 1 to imaginary reference quantity, a reference point where my Mach number is 1, I take the point 2 to the reference state where m equals 1, the star velocity of sound, the velocity of sound associated with this star condition for both the points are the same, which also means T1 star equals T2 star. So, only assumption that is taken here is Q equals 0, W is equal 0. So, the process is still irreversible. So, the temperature here is also the same, like our stagnation temperature, the star temperature is also same. So, this will be on the straight line. So, now if you look at the plot again, I am enlarging that process 2, 1, this is S, T, this is my stagnation condition, somewhere here is my star condition. So, this is the star value, this is the stagnation value. What we obtained now is T star 1 equals T star 2, T01 equals T02 is something which we already know. Both these conditions obtained when Q equals 0, Ws is equal 0. So, the pressure here is different, P01, P02, P star 1 and P star 2. They are also same if the process is isentropic. We have also seen that this distance, this difference between the temperature T0, T1, T01 minus T1. So, what is T01 minus T1? T01 minus T1 is nothing but V square by 2 Cp. So, instead of 1, if I take the star value, this will be T01 minus T1 star equals, I will replace the velocity V1 with V1 star square by 2 Cp. So, this distance is v square by 2 Cp, whereas this distance is v star square by 2 Cp. Now, we further so I have two reference quantities. Stagnation and the star condition. So, if the process is isentropic, this process is also isentropic. Okay. Between 2 points 1 and 2, I have T01 equals T02, here again T1 star equals T2 star. P01, P02 by P01 as e power minus delta S by R. And P02 is less than P01. Likewise, here your P2 star is less than P1 star. And here V, your T01 minus T1 is your velocity square by Cp. Here T01 minus T1 star is your V1 star square by 2 Cp. V1 star square is also your A1 star square, which you can write it in terms of T1 star, and you can write the entire quantity in terms of T. So, if I write T01 minus T1, let us put remove the suffix. So, for any point T01 minus T1 star is V star square by 2 Cp, which is also your A star square by 2 Cp. So, T0 minus T star, I can replace that with gamma R T star divided by 2 gamma R multiplied by minus 1, which is nothing but T star into gamma minus 1 by 2, and I take this star here. So, your T star by T0 by T star is gamma plus 1 by 2. Okay. So, this is nothing from the energy equation, between the stagnation point and the star point. Now, this is an isentropic process. So, I can relate this to P0 by P star as well, because from star to stagnation is an isentropic process. I can use the isentropic relation, get the. So, the ratio of this is again a function of gamma alone. So, if gamma is 1.4, so this is 1.4 plus 1 by 2. So, this is 2.4 by 2.4 by 2, this is 1 point. So, m star is the Mach number at the star condition. It does not mean m equals 1. M star is V by A star. So, if I have a fluid that is moving with some velocity v, for this particular v I have a m star. So, I take the fluid, if this fluid at state 1, if I take it isentropically here, I have a star value, but at this point I also have a velocity v1. So, this m is always 1, because that is the value, that is how we are defined the reference quantity. So, the m star is this v1 divided by this a star. So, this is not equal to 1, it can be 1, but it is not equal to 1. Okay. So, we will talk more about m star in the next lecture or so, when we discuss converging diverging nozzle and flow through converging nozzles. So, the message from this lecture is that we have two reference quantities, stagnation and star, which is very useful in defining this thing, and we have also defined something called m star, because m is always changing with respect to temperature as well, and it is not just a function of velocity alone, and at large velocities m would be tending to infinity, whereas now we have defined a new quantity wherein which we can scale down the whole process to something very small. So, we will discuss further on m star later, that is the